Now, this problem is not asking for exact values, just more or less an idea of what the orbital speed in terms of the mass could be. So that the planet is half as much as the mass, the orbital speed of the planet would be. So basically we have that the force equals the mass times the acceleration. So if we break it down into simple terms, it's the mass times the gravity times the mass over r squared equals mass times acceleration. So the acceleration equals g times m over r squared, which equals v squared over r, because that's what acceleration is for circular motion. So now let's say that the mass is, remember, 1/2 of that planet. So we have the v squared equals gm over r. So now I start plugging in these numbers, and remember that m is approximately 1/2. So you have v squared equals g times mo, which is what we're calling that value, over 2 times r. If we simplify it, it equals 1/2 of gmo times r, which equals 1/2 of vo squared. So we can't have both sides squared, so we get the square root of v squared, or the square root of 1/2 vo squared. So our answer is v equals 1 over the square root of 2v. So here, as we can see, that's our answer, so that the velocity is going to be v over the square root of 2.